Hi, so in this video, we're going to be looking at covariance again, but this time using indicator functions to kind of see an easier example of how things might work. So what we're going to do is first we're going to look at okay, so let's break this down. We need some information. So we're going to let x of a, let me write this down, x of a be the indicator function for an event A, and x sub b be an indicator for an event B. We should also note that xa times xb is the indicator function for an event A and B. We won't go over why this is for now. Just know that if we multiply them, then we get A and B. That's okay. Now the thing we kind of learned is that the expected value of an indicator function is just the probability that this event happens. So in other words, what we're saying is the expected value of xa is just the probability that A happens. The expected value of xb is the probability that B happens. And this final one is the probability that A and B happens. So this is basically kind of like what we have. And so what we can do is looking at covariance of xa and xb, well, this is just, we plug it into a formula, xa xb minus e of xa, e of xb. And this, we have the probabilities, right? So we can just plug these in. So we have p of a intersect b minus p of a times p of b, times the probability of b. So in this case, in the case of indicator functions, what we have is the following scenarios. What we have is that if our covariance is positive, then what we have is that the intersection is going to be, the probability of the two things happening is greater than one or the other, like them separately. So this we call, this we call positively dependent. And we'll kind of see why this happens in a second. If the covariance is 0, then A and B are independent. Note that this is only true for indicator functions. We're indicator functions. So maybe I should write note only true for indicator functions. This if and only if. The one direction is true for all of them, but the other direction is not true for non-indicator functions. And if the covariance is negative, then we say negatively dependent. Now, what does this really mean? Like, where is this coming from? So let's actually look at this. And what we'll remember is, like, when we look at, come on, okay, fix yourself. If we look at A given B, well, what if you recall what this equals to? This is equal to P of A and B divided by P of B, right? This is the thing we had kind of seen. And so what we have is if I have A and B is greater than P of A, well, here I can just divide by P of B, right? I can just divide by P of B, P of B. And so on the left-hand side, I'm left with P of A given B is greater than P of A. And this is why we're saying they're positively dependent. So positively dependent basically says that if A is dependent on B, then the chance that A happens by itself is less than the chances of A happening given B happening. In other words, B helps A to happen in essence. Okay, so let's actually look at this next example, because I think an example would help. And we'll keep this in this video, just since we're rolling along with indicator functions. Or actually, no, I'll cut it. It's been 5 minutes, so I'll see you all in the next video for this next example. So I will see you then. Bye.